Green's function will look like. We have not seen how the Green's function. We found that L star G, this operator is like this. That means we can say L star G equals to 0 if x not equal to z. That means why I am saying this is a delta function at x equals to 0. If it is x not equal to 0, everything is 0. No? Everything is 0. For example, if L star is d2 by dx, that means d2g by dx square is delta x minus. What will be your dg dx? What function you take derivative, you get delta function. What function you take derivative, you get delta function. This is a delta function. The step function, excellent. Step function. If you look at, so that means if you take derivative of this, there is no change of value, it is 0. But at this point, what actually happened? Distance is going to 0. Derivative means what? This is y and x. And this is you are solving, you are getting delta y by delta x. At this point, delta x is 0. But delta y is very high. Some finite quantity, but delta x is 0. That means delta by delta x is infinite. Now, what I am saying, it is z by x and y equals to delta z by delta x. What is z? That means I am trying to find out g. You got my point, right? You didn't get my point. You got this point? You did the derivative, you got this one. I am saying z by x, z is not, y is nothing but delta z by x. What thing I take derivative to get this one? What thing I take derivative to get this one? This is constant, right? This is constant. If a line is constant, see if a line is constant, what thing will be there? If you take derivative, you get line constant. Right? Then it will be like this jump. Here derivative is constant, right? Straight line. Here also constant. Here what happened with derivative? This is the left hand derivative, this is the right hand derivative. We have done it. So left hand derivative, right hand derivative, and this is discontinuity. Why this statement? That's what I want to do. So these are these functions. So this function looks like this is the physical way to visualize this function. So d2g by dx square equals to 0 if x is not equal to 0. dg dx will be what? ax plus b, am I correct? Or a? A is constant. X not equal to 0. G will be ax plus b. X not equal to 0. That means what actually happens at x equals to 0 is discontinuity. Right? That means the G will be straight line around the point x equal to 0. This slope we don't know. Slope decided by A. The slope discovered. So this is the x equals to c. Are not clear? So what actually happens at this point? What are the condition? At x equals to z, gxc plus equals to gxz minus. That is same, right? Another condition you have to get. So at this point, so if you want to find out g is nothing but ax plus b for x less than equals to z, cx plus d at x greater than z. This is the final form of g, right? We agree or not? Because they discontinuity. So both are straight line along the two halves. This is a and b, and this is c and d. You have to find out a, b, c, and d. You need to have four conditions to find four constants, right? What we actually have? We have our l star g equals to 0 for x not equals to g, and the boundary conditions of g. Some boundary condition you get at x equals to 0, x equals to 1. So you got two conditions. We need to have four conditions to evaluate four situations. You already got this one. Another conditions we can get dg dx at x equals to z plus minus dg dx at x equals to z minus, which is called as jump condition. You can see that the derivative is not same, they are different. What is it? What is that? What is that? How to get this condition? So if you get this jump, you get four conditions. Two conditions here, third condition here, fourth condition here. With these four conditions, you can find A, B, C, D. Your Green's function is obtained. Your problem is solved. And that's all the Green's function. How to get this one? How to get this jump condition? Let's take up an example problem. Let's take up an example problem. I'll solve one problem that will be sufficient for you to learn so that you can actually apply the use function. These parts are clear, right? So jump condition has not been resolved so far. I am asking a question. Solve d2t dx square minus dt dx equals to x. Boundary condition t x equals to 0, 1 dt dx at x equals to 1 equals to. Can you solve this problem by this function? Why? Because boundary conditions are not homogeneous. So it's possible to split them. How to split? We have seen that. We can see this is a linear operator. Linear operator problems can be split. What will be our first problem? When it's split, what will actually happen? We have homogeneous differential equation, non-homogeneous boundary condition. We have non-homogeneous differential equation, homogeneous boundary condition. What will be my first problem? We have done this type of things earlier, right? Equals to x. Homogeneous boundary condition, and I say that is first is homogeneous. first problem T1. Otherwise we have problem T1 0 dt1 dx x equals to 1 equals to 0. Second problem minus d2 dx equals to 0. t2 x equals to 0 equals to 1 and dt2 dx at x equals to 1 equals to 0. That's all. This problem you can solve. It's easy. This is already you have done. This is to be solved by Green's function. This has to be solved by Green's function. Okay, how to start with? So first problem will be solved with the Green's function. What is that? LUG JUG plus UL star G. If you know actual problem, many problems are solved. What is LU? D2. So it will be LT1, right? Or L, yeah. Let's find out T1. D2 T1 dx square minus dt1 dx. Left hand side. Start. What is left hand side? Integral 0 to 1 d2 t1 dx square minus dt1 dx g dx. Next step. Very simple. 0 to 1 d2 t1 dx square g dx minus 0 to 1 dt1 dx g dx. Next step, we have to find out the bilinear concomitant. Which is u, which is v? Find out. Which is u, which is v? Similarly, same thing here also. You should be having operator in terms of g. In terms not in now in operator in terms of t1 operator is there. It will be in terms of g operator. What is that? What it will lead to? Bilinear concomitant. You should not be thinking so much. We have done it. It is very easy actually. What is that? G of g is not the function of x, it is function of x and z. How can you say g is the function of x? If it is g function, you have seen it, it is like this or like this. It is a discontinuity x equals to z. So g is the function of x and g. G is the function of x and g. You cannot say g is the function of x, then there is no indication of discontinuity, right? You have a discontinuity, you have proved it. Okay, you tell me the answer now. What is the bilinear concomitant and what is the operator? First bilinear concomitant. dt. What is that? dt is there. You have eyes, I guess. Your eyes are there, I guess. dt1 by dx g1 minus g0, then minus what is that? 0 to 1 dt1 dx, sorry, minus t1 prime. t1 prime is already there. t1 g prime, right? Plus, then minus or plus? Binary concomitant over. I want to have operator from here first. Integral 0 to 1 d2 g by dx square t1 dx. Next this one minus g0 g1 T11 plus G0 T10 plus integral 0 to 1 e dg dx. Am I correct? Now this term, this term, this term, this term, and this term, this term, these will constitute binomial conformity. This is your JUG. It has to be 0. Otherwise problem. Otherwise you cannot predict it. What are the conditions here? We can see the conditions. Boundary conditions are homogeneous. That is T1 at x equals to 0 equals to 0. And dt1 by dx at x equals to 1 equals to 0. Right? So we can actually formulate your H star g delta x minus z. So what is your H star g operator now? d2g j square plus dg by dx equals to delta x minus z. Delta x minus z. Then what's the boundary condition? Such that jug equal to 0. Such that jug equal to 0. So these two terms you got 0. Now you have to get this term 0, this term 0, this term 0. See T1 0 is 0, so this term is also going to 0. So we can say G0 equals to 0, so then this term will go to 0. And then G prime 1 equals to 0. G prime 1 plus G1, remember that. You cannot say G prime 1 equals 0, this is still remaining. So G prime, and they are the same sign. And T1 is also there, right? So G prime plus G1 equal to 0. Am I correct? G prime 1 plus, you can write this way, G prime 1, G1 equal to 0. It's a very tricky problem. Yes or no? So G prime 1 plus G1 equal to 0. So this is your Green's function problem. Amit, any problem? Clear? This part is clear, G prime 1 is 2. Now your point is, if you solve your problem is done. You have got the last step. You have got the last step of the problem. How to solve this problem? How to solve? d2g dx square plus dg dx equals to 0 for x not equal to 0. Right? Then next step. This is very easy to solve. This is nothing. This already we have done 10 plus 3. This is nothing. This type of problem we have done now. Take trial solution e to the power mx n square plus 1 equal to 0. Solution is m equals to 0 and n equals to minus 1. See, without calculating I am getting the solution. Then what will be your GHG? Equals to what will be your GHG? What is that? A plus b e to the power minus x for 0 x less than z, right? Left up, right up. C plus d e to the power minus x, z less than x less than. Conduct clear? Yes or no? Amit? No, right? We have just discussed why it is like this. Right? Clear? You have to find out A, B, C. Immediately what you do, you apply this boundary condition. Boundary conditions are there. G0 equals to 0. G prime 1 plus G1 equals to 0. If you apply, what you get? If you apply, what you get? Yes, what you got? Any values you got? Apply B and C, what you got? Some relationships you will get. A plus B equals to, you are very correct. So applying boundary conditions. Applying boundary conditions. A equals to minus B and then C equals to excellent. You understand everything? Very good. Next, two weapons we have in our hand. Continuity of this function. Apply that. And last one is jump discontinuity. Last one is jump discontinuity. Continuity, that is g x z plus equals to z x z minus. What will you get? If you apply the continuity, this is your z minus, this is your z plus. First one is z minus, second one is z plus. You get a relationship. If you apply the continuity, you get a relationship. What you get? What is that? A. Okay, A equals to B by if you for x, you are applying at x equals to z. Remember that. You are applying this condition x equals to z. Yes. So A equals to B by e to the power z minus 1 or B equals to B by 1 minus e to the power z. Is this part clear to all of you? Is this part clear to all of you? Nikita? What's about this page? Clear? If we apply the condition, what actually happens? A plus B e to the power minus x at x equals to z equals to c plus d e to the power minus x at x equals to z. So there is no question to have z in the final expression. Okay? And a equals to minus b. Okay? And if you put it, you know the solution. So if you put it, it will be b minus 1 e to the power minus z equals to d e to the power minus z. C is already 0. So, and that will give the final expression. Last condition, which is called as jump, because we found that this relationship is there, but we have not got anything concrete. Okay? What is the last condition? Jump discontinuity. How to get the jump discontinuity? d2g by dx square plus dg dx equals to delta x minus z. Do integrate each term between x equals to z minus, x equals to z plus, z minus, z plus, z minus, z plus. What you get? If you look at, it is ddx of dg dx dx. That means what you get? Differential of dg dx. That means dg dx at x equals to z plus minus dg dx at x equals to z minus. This term will give. Do you agree or not? You want me to explain more? Do you agree or not? Or you want me to explain more? Yes? You want to explain me more? I will tell you how simple thing this is. And now you can see your level of mathematics. d2g dx square dx x equals to z minus x equals to z plus x equals to z minus x equals to z plus ddx of dg dx dx. This will go and it will be x equals to z minus x equals to z plus differential of dg dx. Do you agree or not? Then what will happen? Integral differential of x, integral of dx, x1, x2. What will you write? x2 minus x1. Yes or no? So what will happen? It will be dg dx at x equals to z plus dg dx at x equals to z minus. That's why I wrote
minus.
Z plus minus. Yeah, that's okay. Any question now? See, this is so simple. Next step, dx of g, that means you get g of xz at x equals to z plus minus g of xz at x equals to z minus equals to 1, right? This is 0, no? They are continuous. That means jump discontinuity equal nothing but 1. So you got a new boundary condition. So this will vary from problem to problem. That's why I didn't say anything. This will vary from problem to problem. If you have other differential operator, you get different kind of. So jump discontinuity has to be derived from the L star G operator. So last condition, jump discontinuity, which is dg dx at x equals to z plus minus dg dx at x equals to z minus equals to 1. How much you are getting? If you apply, what you finally get? If you apply this, you take the derivative first of this. If you take derivative, what you will get? Minus b to the minus x. Minus d to the minus x. Okay? Then at x equals to z, then no z, no x will be there. Only z will be there. Okay? If you do that, subtract it, equals to 1. What you finally get? You get d equals to something. D equals to 1 minus p to the power c. You are very, very correct. And then tell me all the constants then. Now I want the answer. Gxz equals to Gx equals to Gx equals to minus 1 plus, then it is 0 x less than z. Next 1 minus e to the power z e to the minus x z less than x less than. Right? Can you draw the Gibbs function? Next question. This kind of question I asked in the exam. Can you draw the Gibbs function? Can you draw the Gibbs function? So what actually happens that this is your domain x equals to 0 to 1 and z also will change from point to point. So along z it will be like this. Like this. Z values are also changing point to point. You pick up some representative z values, so 3 or 4 values, say 0.2, 0.5, 0.25, 0.5, 0.1 or 1. What will be the Gibbs function? Up to this everything is clear. Gibbs function. And what's the final solution then? Your final solution is, if you look at your expression, what's the final solution? The final solution is LT1G equals to T1 L star G. Am I correct? The J term is 0. Bilateral concomitant is 0. Okay? LT1 is what? LT1 is x, right? Xg equals to, what is that? T1 L star G? Delta x minus g. It will be T1z, right? It will be T1z. So this is a dummy value. This is a dummy value. This could be x also. So in that case, what actually happens? We can write t1x integral 0 to z minus 1 plus e to the power minus x dx plus z to 1 minus e to the power z e to the power minus x dx. Am I correct? Yes or no? That's the solution for T1. Can you get me that, sir? Integrate and get me the answer. Integrate and get me the answer. Yeah, you want to integrate? Or you want me to integrate? Because I want to practice, because this problem is coming, this type of problem, not this problem. I won't give this problem, you mind it, because solution I am giving. Maybe after 2-3 years I will do the same way. I hope that your stand is not that bad. You can at least try, but if your stand is bad, then I can give the same problem. Z to 1. So what actually happens? You will get initially the function of z, but z and x can be interchanged because they are dummy variable. So you finally write in terms of x. You will see that. That's why I want you to do that problem. You will get the solution in terms of z, but z and x can be interchangeable. The dummy variable, right? Z is a variable, x is also a variable, right? How to integrate? I am asking for integration, nothing else. This term will be integration by parts. Here will be integration by parts. E to the power z is constant. E to the power z is constant. Integration by parts is there. That is very simple integration by parts. What is that? Very simple integration by parts. Yes, has it been done? Integration by parts. You will get in terms of z function. That's what I want. You get in terms of z function. get in terms of z function. Yes. How many terms are there? 4 terms. 4 terms I am getting. You tell me the terms, then I will figure it out. Nikita. Plus z, no. Minus z, right? Minus z plus 2 even plus z. Plus z minus 1. Then another term. Minus 2y. Okay, so the final form is, so you'll get from here t1z. Okay, you'll get t1z, which is minus z square by 2 minus z plus 2 to the power minus 1 minus 2y. And essentially t1 is, we can write as the dummy variable minus x square by 2 minus x to the power x minus 1 minus 2y. And t2 you can get. T2 you can easily obtain, right? How much is T2? How much is T2? T2 you can easily obtain, that I don't know to find out. Then you add T1 plus T1 and T2, you get the final solution. So you learn Green's function. Finally, we have learned Green's function. So Green's function, I will be giving the problem in the end semester only one dimensional. So only ODEs I will be covering, not PDE. So Green's function only ODEs, that means you know Green's function and how to apply. So any differential equation I can give, you can find Green's solution by Green's function, right? Any questions, any doubts? Any questions or any doubts? Another problem, quick problem I am giving before entering the Green's function part. The differential equation is minus dtu by dx square equals to fx. The boundary condition q0 equals to 0, u prime 1 plus alpha q1 equals to 0. I want the Green's function for this problem, but you tell me what is the operator for Green's function and what are the boundary conditions for the Green's function. Then you can easily find the Green's function. I want to check that whether you can do the adjoint theorem correctly. What is the Green's function operator? And from the bilinear concomitant, what are the Green's function boundary conditions? What are the Green's function boundary conditions? Did you get the Green's function operator and boundary conditions? Remember that you have to make bilinear concomitant 0. You have to make bilinear concomitant 0. make binomial concomitant 0. Yes, what is that? What are the boundary conditions? What is that? G of 0 equal to 0 then? G prime 1, G prime plus alpha G at 1, x equals to 1 equal to 0. Okay, so I think you can practice these problems from your textbook. Textbook, I think a lot of example problems are there. You can practice so that you can actually try to solve many problems from the textbooks. And next class onwards, I will be doing numerical techniques. So Monday onwards, we will be having numerical analysis. So this is the end of the analytical forms. Okay. So next couple of lectures, I think 2 more weeks will be there to go. 7-8 lectures will be doing numerical analysis. Thanks for the attention.